Hi guys, welcome back to another video. In today's video I will show you how to do implicit differentiation. And the implicit differentiation, it's used when we cannot express a function in the form of y equals f of x. So for example, if you have x cubic plus y cubic equals negative 8xy. So it's hard to solve for y in terms of x. So we can still find the f prime using the implicit differentiation technique. And this method has 3 steps. So the first step is differentiate both sides of the equation with respect to x and treat y as a function of x. Step 2, collect dy over dx or f prime on one side and then solve for dy dx or f prime. So let's apply these 3 steps in these concrete examples. So the first example here, we have 2xy plus y squared equal x plus y. So let's do step 1, differentiate both sides. So I'm gonna differentiate both sides. So 2xy, so this using the product rule. So 2 is just constant, so I'm just gonna leave 2 alone. So x prime times y plus x times y prime. So this is the product rule, plus, so using the power rule for y squared, so it's 2y, but y is a function of x. So using the chain rule, it's going to be 2y times y prime equals x prime plus y prime. And now we can simplify and collect f prime in one side. So it's going to be 2x prime. So x prime is 1, so 2y plus 2x y prime plus 2y y prime equals, so x prime is 1 plus y prime. So I'm gonna subtract 2 y's from both sides. And subtract y prime from both sides. Because I want y prime by itself to solve for it. So on this side, I'm gonna end up with 2x y prime plus 2y y prime minus y prime equals 1 minus 2y. And now factor out y prime on the left hand side and do step number 3, solve for y prime. So y prime here, 2x plus 2y minus 1 equals 1 minus 2y. Now dividing both sides by 2x plus 2y minus 1 give me y prime. So y prime equals 1 minus 2y divided by 2x plus 2y minus 1, and that's my final answer. That's f prime of that function using the implicit differentiation technique with the above 3 steps. So let's apply the same steps in example number 2, which is x equal tangent y. So first step, differentiate both sides. So x prime equals tangent of y prime. So x prime is 1, and the derivative of tangent is secant square. So secant square of y, but using the chain rule, because y is a function of x, times y prime. Now step number 3 is solve for y prime. So y prime, it's 1 over secant square of y, or cosine square of y, because 1 over secant is cosine, and that's my f prime of the above function. And let's do last example here. So last example, we want to find the y prime of this function. So e power 2x equals sine of x plus 3y. So step 1, differentiate both sides. So e power 2x prime equals sine of x plus 3y, the whole thing prime. So here, using the chain rule, it's gonna be e to the x, 2x, times the derivative of 2x, which is 2. Same thing here, the chain rule, so the derivative of sine is cosine of x plus 3y times the derivative of the inside function. So that's the chain rule. Simplify a little bit, so it's going to be 2 times e power 2x equals cosine of x plus 3y times the derivative of x is 1 plus 3y prime. And now I'm gonna divide both sides by cosine x plus 3y. So 2 times e power 2x divided by cosine of x plus 3y equals 1 minus 3y prime. And then subtract 1 from both sides. So 2 times e power 2x divided by cosine of x plus 3y minus 1. So sorry, that must be plus, so there is no minus here. So the derivative of 3y, it's plus 3y prime. I don't know why I put negative, but it's 1 plus 3y prime. So minus 1 on both sides equals positive 3y prime. And now let's find the common denominator and combine the left hand side. So it's gonna the common denominator, it's cosine of x plus 3y. So cosine of x plus 3y, and 2 times e power 2x minus cosine of x plus 3y equals 3y prime. Now if we divide both sides by 3, we are done. Now let's do it. So now y prime will be 2 times e power 2x minus cosine of x plus 3y, the whole thing over 3 times cosine of x plus 3y. And that's my answer. That's my f prime using the implicit differentiation technique. So I hope you enjoy watching this video. I will pause here and continue next time. Thank you for watching.